Good day, everyone!
For today's class, we are going to discuss the nomenclature of
ketones,
aldehydes,
phenols,
ester,
and carboxylic acid.
Hi, I am Jaylene Salido and I am going to discuss the nomenclature of ketones. Ketones is a group of organic compounds that have two alkyl groups attached to a carbonyl group and named by replacing the suffix "-ane with -one. Let's take a look on how to name ketones. First, find the longest chain and number from the end closest to the ketone. So 4 carbons is but and add the suffix -one. Say double bond O is in carbon 2. Therefore, the IUPAC name of the structure is 2-butanone. If there are 2 carbonyl group present, we also have to find the parent chain and the location. Therefore, we have 2,4-pentane and add the prefix di because there are 2 carbonyl group and add the suffix -one. Now, let's try to draw the structure of 3-methyl cyclohexanone. First, we have to draw the parent chain cyclohex having 6 carbons. In cyclic ketones, the carbonyl group is assigned location in position 1. And we have here the substituent methyl located in carbon 3. So here is the structure of 3-methyl cyclohexanone. Additionally, wood coatings and inks are just some of products developed using ketone.
Hi everyone, this is Erica and I will be discussing how to name and to draw the aldehyde functional group. Aldehyde is an organic compound which incorporate a carbonyl group and the structure have 1 hydrogen in one side of the molecule. Aldehydes are going to be named similarly to alcohol but in all ending. The double bond and oxygen are placed at the carbon 1, which means we don't need a number to tell where is the double bond and oxygen is, because it has to be in the very beginning. So how to name an aldehyde group? In naming aldehyde group, identify first the longest carbon chain in the structure. In this example, we have a 4-carbon aldehyde. Therefore, the structure prefix is buta. After that, add the suffix for aldehyde, which is -al. Therefore, the IUPAC name of the structure is butanol. Now let's discuss how to draw an example of aldehyde, the hexanol. Identify also the longest carbon chain based on the prefix of the given name. The prefix is hexa, which signifies that the longest carbon chain is 6. After that, draw a hexa backbone of the structure. After that, add the aldehyde in the first position or in carbon 1. And that is the structure for hexanol. Additionally, aldehydes occur in natural products like cinnamon bark and vanilla bean.
Hi everyone, I'm DANAY and I will be talking about phenols. What is phenol? Phenol is also known as carbolic acid. It is an aromatic organic compound with the molecular formula of C6H5OH. This molecule consists of a phenol group bonded to a hydroxyl group. Now, let us continue at naming of phenol. Phenol is one where OH directly attached to the benzene ring. So here is an example on how to name a phenol. OH is the phenol. This will be our carbon 1. So let us count in around to get the lowest number. Methyl group is on carbon 3. So this will be 3-methylphenol. So here is another example for naming our phenol. So in naming them, we start off numbering the carbons where the H is found. And in our compound, we have the substituent Br or bromine. So let us start counting in clockwise form. This would be carbon and carbon 2. So we have bromine right here. We write down 2-bromo since the bromine is in carbon 2. and base for this molecule is phenol. So, 2-bromophenol. So, since the OH and the first substituent occurs at 1 and 2, we use O-bromophenol. So that is it about phenol and naming phenol.
I am Raymart L. Villanroque and I'm going to discuss about ester. An ester is a molecule that has an R group which represents your parent chain attached to an acyl or carbonyl group, which is a carbon double bond to an oxygen and attached to a single oxygen. So in this video, I will show you how to name an ester. So first, we are going to draw an ester. To name this ester, first is find the carbon chain that has the double-bonded oxygen on it. Only one of them is going to have the double-bonded oxygen because the single-bonded oxygen is what's breaking the carbon chain into two separate chains. So in our double-bond oxygen in here, we have 4 carbon chain. The 4 carbon chain associated with butane, but since that's gonna be our parent name of the functional group, we are going to add the suffix OH, which represents the double-bonded oxygen and single-bonded oxygen. So we will call it butanoate. In our single-bond oxygen, we have here a 3-carbon chain. The 3-carbon chain associated with pro, but in additional of our prefix YL, we are going to call this a propyl. So the name of this ester is propyl butanoate. So now I am going to draw the structure for ethyl pentanoate. The OH here tell us that we have a functional group of COO, carbon, double-bonded oxygen, and single-bonded oxygen. The pent right here tell us that we have a 5 carbon in the parent chain. The eth right here tell us that we have a 2 carbon attached with our single-bonded oxygen. And that's how to draw a structure for ethyl pentanoate.
Carboxylic acids are named based on the number of carbons in the longest continuous chain, including the carboxyl group. How to name a carboxylic acid? In naming a carboxylic acid, remember that it ends in oic acid, which is a suffix for carboxylic acid. Also, the chain is numbered beginning with the carbon of the carboxyl group, which means the carboxyl group is placed at one end of the carbon chain. Just like naming any other organic molecule, we need to find first the longest carbon chain. In this example, the longest carbon chain is 4, which means that the prefix is but. Instead of calling it butane, we will replace the suffix to oic acid and it will become butanoic acid.
Now let's draw the structure of pentanoic acid. So the oic acid here tells us that we have COOH present in the structure. And the pent right here tells us that there are 5 carbons. Since the carbon in COOH is always the first carbon, therefore we have to add 4 carbons here. So this is the structure of pentanoic acid. Furthermore, carboxylic acid occur in natural products such as lactic acid and citric acid. So that would be all for today. Thank you for attending the class. Class dismissed.